So now we have finished our mid-chapter checkpoint of chapter 2. And in that mid-chapter checkpoint, we checked on 3 different functions of fractions. We can add fractions, we can subtract fractions, we can multiply fractions, and then we included in that 4th lesson the cross-reducing. Now this lesson is not designed to be difficult, but I do have some students in the past couple of years that have kind of struggled with it because this is a thinking lesson and I have to draw pictures in order to go through my thinking process. It's really trying to build a comprehension of what fractions are talking about. So that's where we have to start. I'm not saying that there isn't anyone in our class that doesn't understand, but having this foundation reminded in our brains before we get into the practice problems, hopefully it'll help you see what it is we're talking about. So when we have a fraction, then I know that my denominator is telling me how many equal groups I'm talking about. So let's say I have a pile of 100 jelly beans, and I want to split them evenly amongst 20 people. So I'm going to have 20 individual piles of jelly beans. Well, let's say somebody really earned a special reward, and they got 3 of those piles. So my numerator then talks about how many of the groups out of my denominator I'm talking about. So if I understand that my denominator is always telling me the number of groups, and my numerator is always telling me how many of the groups, then thinking about these type of problems hopefully will make more sense to us. Be sure you're following along because I'm going to be putting shapes up here because that's what we're going to do is we're going to use number bars. It's basically rectangles and squares in order to solve these problems. So you might have to do some extra drawing, which means you'll have to probably pause the video as we go through it. So as we get into chapter 2, lesson 5 then, it's trying to get us to think about what we're talking about. So in here, we're looking at 2/3 divided by 4. Now, we can't actually divide fractions by whole numbers, nor can we divide it by fractions, which we'll get into in a couple of lessons. But right now, we're just looking at if I have 2/3 of something, and I want to divide it into 4 equal groups, what does that look like? Well, notice that in the diagram they've given you, they have one whole, and then we have a third, and a blank. I've drawn this black box because I'm going to be constantly looking back at a whole so we understand we have all of the pieces as we go through this lesson. So it might help you to go ahead and box this in directly underneath to show that we have some missing information here. I know that I'm talking about taking my one whole and putting it into groups of thirds, right? Because it says I'm going to use 2 groups out of the 3. So if I'm showing I have 1/3 and 1/3, then that missing portion right there is also going to be 1/3 because it's going to be dividing my one whole into 3 equal groups. Each of those would therefore have the value of 1/3, and 1 plus 1 plus 1 does give me 3. So that's going to be my value of one whole. When I'm talking about 2 of those, then I'm talking about specifically these things. But then I look at those things that I'm talking about and how many groups am I putting those into. So if I'm putting those into specifically different groups, then I know I'm going to have 4 that the 2/3 is divided into. So notice I have, this line would be divided also because this is a group of 4, so that would have to be divided into the same amount. When I have those 4 then, well, what would those be called? Here's why I'm showing the entire one whole. Because if I'm not sure what that would be called, then I would just simply count how many of the little boxes I have. That becomes my denominator. Well, I have 1, 2, 3, 4, 5, 6, right? So if I have 6, then I know my denominator of whatever these fractions are going to be has to be 6. And each of them has to have a value of 1/6. So if I'm taking 2/3 and I'm dividing it into 4 equal groups, then what fraction do I have? Well, I have 1, 2, 3, 4 of those fractions. But what are we trying to find? That's the question that they ask you. So I'm trying to find how much is in each group of 2/3 if it is shared by 4 different people. Well, in each of those groups then That's what these little itty bitty fractions are telling me. Each one of those groups, if it's divided equally amongst 4 people, is going to be 1/6. So it doesn't matter what, now the story that happens to be talking about walking miles and things like that, and how much of that distance each person is going to be doing for the team. But it doesn't matter what we're talking about in sharing. It could be sharing food, it could be sharing distances, it could be sharing the amount of pages to read for a trade book. The idea is, if I have 2/3 of it, and 4 people are going to share that amount, then each of those people are going to have 1/6 of the overall total to do. Okay, so let's look at the next one. On B, it says another team clears a section of the path that is 3/4 of a mile long, and if each student clears 1/8 of a mile, how many students are on the team? So now we're kind of switching our question, right? We're not saying, well, what's the small fraction for each of those people? What we're saying is, if I have the small section, how many people would that give me? So I'm going to take my 3/4 divided by 1/8. Well, what does that look like? Well, once again, I have my one whole that we're going to talk about. I have to look at what it tells me that my original groupings are that I've divided it into. I'm dividing it into fourths, and I'm going to talk about 3 of those fourths. But that's why I'm always going to add this little extra box here so that I can fill it in and see that I am talking about one whole overall. When I have my one whole overall and I know I've divided into fourths, then that tells me that that's another 1/4. Even though I'm not going to keep it, it still lets me see that I have my one whole there. Now I look at, okay, if I'm talking about 3 of these and I've divided them into groups of 1/8, what does that look like? Well, the 1/8 tells me that I have 8 different groups. Looks like I missed one of my lines there, so I apologize. In order to do my 8 different groups, I have to take my one whole and divide it into 8 groups evenly. Doesn't matter that I'm not going to use this section, because I'm still talking about out of one whole, and it would be divided into 8 equal groups. So if I have my lines, once again, apologize for not having that line, then I have to look at, well, how many people am I talking about? If I have 3/4, my original set, and everything is divided into groups of 1/8. So none of this is going to work. But when I look at it then, what I'm trying to find is how many of the 1/8s are in 3/4. Well, when I count them, I have 1, 2, 3, 4, 5, 6. 6 1/8s that are in the 3/4, right? So my answer is just simply going to be those 6 that I can put them into. So I could go in reverse direction, right? I could say that if I have 3/4 and I'm going to divide that evenly amongst 6 people, I would still see that I would have then, they would be small groups of the 1/8. So I can interlock those and do the opposite division. I could also look at how that's related to. It says to explain how the model in problem A, this one up here, shows a related multiplication fact. So we haven't talked a lot about it yet so far this year. But when we start getting into a lot of different problems with adding, subtracting, multiplying, and dividing, we're going to talk about fact families. And every grouping of numbers that has either adding or subtracting or multiplying or dividing, there's a total of 4 questions that I can get, 4 different math problems or questions that I can get just by switching my numbers. So for example, if I have 2 plus 3 is equal to 5, my second one would be I'd switch my 2 and my 3. I could do 3 plus 2 is equal to 5. The opposite of adding is subtracting, so I could say, well, if I take my answer, my 5, I could do 5 minus 2, and that's equal to the 3. And 5 minus 3 is equal to that 2. So I can take all 3 numbers and create 4 different math problems. When I look at this problem, we could take the 2/3 and we could say, well, instead of dividing it by 4, when we know that I end up with 1/6, I could divide it by 1/6 and I would see that I would get 4. The opposite of that is going to be multiplication. What that shows me then is that if I have my 4 groups of 1/6, that if I multiply those together, that's going to be equal to 2/3. So the math problem would be, well, 4 times the 1/6. That was the two answers I got, right? If I take 2/3 and divide it by 4, I see I get little groups of 1/6. If I switch those two and I take 2/3 and divide by 1/6, then I get 4. So if I multiply those two answers that I would have gotten, 4 times the 1/6, what do I get? I get my original 2/3. So I can come up with 4 different problems that I can do and still get to a group called a fact family. So this one says, suppose a whole number is divided by a fraction between 0 and 1. Is the quotient greater than or less than the dividend? Explain a given example. So if the dividend of 4, if I take it and I divide it by 1/2, then I'm getting 8 different groups, right? Because I'm taking a large number and I'm dividing it into little itty bitty pieces. Well, those number of pieces has to be larger than my original number that I had. So anytime that I do that, I am going to show that my answer, my quotient, is going to be greater than the actual dividend, the number on the inside, that I was dividing into groups. Because when I divide, I put it into smaller groups than my original whole that I started with. All right, so let's go through some more practice problems. It says Jessica is making a recipe that calls for 3/4 cups of flour. Suppose she only has a 1/2 cup size for her measuring scoop. How many 1/2 cup scoops of flour does she need? So what they're saying is she needs 3/4, but all she has is a 1/2 cup, which is less than 3/4. So how much of that 1/2 cup does she have to use, or how many times does she have to use it to get to the right amount of flour? Well, once again, we're going to look at one whole overall. And I know that that one whole is divided into 4 equal groups. And how do I know that? Because that's what my first denominator tells me. I always look at the first one, which is my dividend, okay, in order to tell me what my equal groups are that I've been divided into. I know I've been divided into 4 equal groups. So I have 3/4 of the entire whole, which means we're not going to use that last one, and that's okay. So I have 1/4 and 1/4 and 1/4, and then that 1/4 I'm not even going to use, but I still like to know out of a whole what it is that I'm talking about. If I then am going to divide that into half groups, so that one whole is now going to be divided into how many equal groups? Okay. So I'm talking about a half of a whole, right? So I know that I'm going to be divided into 2 equal groups. So it's going to divide it directly in half from that one whole. So how much do I use then when it comes to this? Notice where it cuts off for that last 1/4 that we're talking about. I can't use that, can I? So if we're talking about just 3/4 and I only go halfway of that second 1/2 cup, then I know that I'm talking about 1 of the 1/2 cups and then half of the 1/2 cup. So what it's saying is, if I need 3/4 of flour and I only have a 1/2 cup measuring cup to do it with, I'm going to scoop it in and level it out and use 1 of those. That's my 1/2 cup. But I only need 3/4, so I have to use that another half of a time. So I'm going to scoop it in and try to shift some of it out and make sure that only half of that is filled up. Then I would end up with my 3/4. So I would use it 1.5 times. Because notice, once again, going to what we're talking about, it goes over 1.5 of the way. All right, so now, here's our practice problems, and this is what our homework's going to look like. So make sure, once again, we're following along and paying attention. I know some of you are going to be going, oh, this is so confusing. Well, it's more because you're used to just having a straightforward math function, and how do I do the math? Just tell me the steps. I'm not going to tell you the steps yet because we're not ready for the steps. Comprehending how math works and what we're talking about, that's the important part. Because if I understand how these numbers work together, I can always be successful and figure something out. So they give us 2 pictures to start with. I changed these pictures because we always want to talk about one whole, and then we don't have any pictures, so we actually have to build from scratch down below. This says I want to take 1/2 and I'm going to divide it into 3 equal groups. Well, I'm never, once again, talking about just a half. I'm always talking about one whole so that I can see that everything's going to be divided up equally. And one whole is the same as a half and a half added together. So you need to extend your picture about the same. Now, I'm not grading you on your perfect artmanship, okay? So do your best to make them look pretty even. In the same way, then, if I'm dividing that into 3 groups, I'm also going to divide that into 3 groups. The only difference is when I start looking at my numbers, that section is not going to be used and I'm going to ignore it. But it helps me see that everything truly is going to be equal. My numerators are always going to be 1 when I'm dividing everything equally. But then I just count my boxes out of the one whole to see what that denominator is. How many even boxes did I create out of the 1? Well, I have 1, 2, 3, 4, 5, 6. So my denominators are all 6s. That would give me my one whole. That focuses in on just 1/2. I divided it into 3 equally, which is what it says. And I divided this one into 3 equally, which is what that says. So I know that I'm on the right track. But then I just cross that section out. Your X doesn't have to be as fat as mine. That was just the icon that kept popping up. So you can make a thin X, that's fine. I just don't want this to distract you on how to solve for your answer. But without that, it's kind of hard to truly understand what we're talking about when it comes to those numbers. When I have my 1/2 and I've divided it equally amongst 3 things, then I can see that each of my little individual pieces, because that's what I'm talking about. If I have my large group of 3, then what do each of them get? Well, they each get 1/6. So that's my answer. Here's the problem that often happens if we don't build the entire 1. I have people that have 1/3, 1/3, and 1/3. Well, think about that. If this is 1/3, 1/3, 1/3, and I don't want to put forth the extra effort to make the one whole and draw all those boxes, 1/3 plus 1/3 plus 1/3 equals what? It equals 1 whole, doesn't it? Can 1 whole be the same as 1/2? It can't. That's impossible. So if I draw the entire 1 whole, that lets me see then that I'm not talking about thirds, I'm actually talking about sixths. Because this other half also has to have 3 divided equally among them. So once again, I'm not asking for perfect artwork, but I'm talking about legible that I can understand to help me think logically what this is asking me to do. And it's asking me to take 1/2 and divide it amongst 3 people. I always apply this concept for me about people getting something. I don't care what it is that they get. Maybe it's a half a pizza and those 3 people are going to decide how much a half of a large pizza is, and they get 1/6 of it. That works. When I go to the next one then, I can see that it's already divided into the small pieces that it's talking about. If I talk about 3/4 all together, then my 3/4 is already drawn, isn't it? So I have 1/4, 2/4, 3/4. I have 3 of them. Well, in order to make sure that all my numbers are going to be correct and lined up, then I would want to make sure that I'm talking about 1 whole. But notice what they've already done for me. They've already put these into my 1/8 pieces for me. Now, denominators tell me how many equal groups that I'm talking about, right? And then my numerator would be, if I added all those together, I should get my 1 whole. So I have all 8s, and I have 1, 2, 3, 4, 5, 6. That's only 6 out of my 8. So if I added my 1/4 over here, and I divided it into 2 equal pieces like these are, then I would have my 7/8 and my 8/8. So it is divided equally and divided correctly into smaller groups. So then this question is asking, well, how many of those smaller groups are there? If I have 3/8 all together. So I want to take my 3/8, the small pieces that's divided into, I want to take my 8s and put them into the numerator. It says in groups of 3. So how many groups of 3 would that be? I would have 1, I would have 2, and I'm not worried about the rest of it, right? Because I would just mark it off anyway because we only have 3/4. So if I have 3/4 and I divide it into 3/8, the little groups, how many of those groupings do I get? I get 2 of them. So once again, I'm going from taking a fraction, dividing by a larger number, and I get the little itty bitty fractions. But if I take my fraction divided by the little itty bitty fraction, then I can see how many large equal groups that I'm talking about. All right, so now let's try 3. This is kind of like this one, right? So I'm going to take my fraction and I'm going to divide it into the big number to see what my little itty bitty fractions are going to be. So I have 1/3. Now, I want to create something to show me what the 1 whole is, so I know that my little itty bitty fractions have the correct denominator. So I'm going to show all 3 boxes that would make 1 whole. So I have 1, 2, 3 of them. Try to make them equal size. Try to make them, divided equally. So I have 1/3, 1/3, 1/3. Then I know that from that 1/3, I'm going to divide each of those into 4 equal pieces. So underneath it then I show each of my 1/3s divided equally into 4 equal pieces. Because if I say, well, I'm not going to do that, that's extra work, all I need is this and this, then what I end up with is dividing this and having a denominator of 4. That's going to completely change my answer, which is not what I want. So if I know that I'm talking about 1 whole, and this is my first third, my second third, my third third, and each of them has to be divided into 4, which is what that says, then I have 4 here, 4 here, 4 here. So how many of those little boxes do I now have? Well, I have 4, 8, 12. I have denominators of 12, right? And we said our numerators are always going to be 1, because I'm talking about 1 of them. So I now have 1/12. I created 12 little boxes for the 1 whole. All right. Well, if that's the case, then I don't need that whole section over there. So now I can focus here. If I take 1/3 and I divide it into 4 equal pieces, what's the little itty bitty fraction that I end up with? That's where I'm going to put that each of them would get 1/12. Now over on 4, like the one up above, I'm going to take a fraction and I'm going to divide it into small fractions again. This is where I want you to think about everything we just talked about, and I want you to see if you can solve for that answer. Once again, I'm not grading it, so if you're wrong, it's okay, and I'll be showing you the correct steps to make sure that you get to the right answer. But I just want you to try. So if you haven't followed along, you haven't filled out this information, and you've just stared off into space, and then when you see something's written down, you try to write it down real quick. Please rewind, because it's once again going to be a shorter video. Rewind it, rewatch it, so you understand what we're talking about. For some of you, this is a really difficult concept, and for some of you, you're like, oh, I can understand pictures and diagrams. That makes much more sense to me, and it's going to be easier for you. Okay? But I want all of you to try number 4, pause the video, and then come back to me. All right, so hopefully on number 4 you have an answer, but you've also showed your work. And showing your work on this assignment is by drawing boxes. So you have to be willing to get out of your comfort zone if all you want is math formulas and numbers and a process to do it. Because that's not what this lesson is about. And this is going to be on your test coming up next week. So when I have my 3/5, then I know that I'm talking about 1 whole overall, and that it's divided into 5 equal pieces. So we should have started with making a long rectangle and dividing it into 5 equal pieces. Once I have that, then I know that each of those are going to be 1/5, because it's 1 out of the 5 different pieces. And then I know I'm going to divide my 1 whole into how many equal pieces? 10, right? Because my denominator says to divide it into 10 equal pieces. So I duplicate that box, but now I make sure that I divide it into 10 equal groups. Now, if I've already divided it into 5 equal groups and I need 10, that's 2 each, right? So if I just divide those boxes in half down below, now I have my 10, 2, 4, 6, 8, 10. I do, so I'm good to go. So I have my denominator of 10, I've done that. Each of those have a value of a numerator of 1, because they're each one of the tenths, and my denominator is 10. All right, so I'm good. Now remember, then I can cross that out because I don't need that but it helps me get to the right fractions knowing that I'm talking about one whole. Now it says to divide them into groups of 3/10. So how many groups of 3/10 do I have? So then I would box around. Since my numerator says 3, I have 1, 2, 3. That's one grouping. 1, 2, 3. That's a second grouping. Once again, just like above, I should have gotten an answer of 2. If you didn't get an answer of 2, or maybe you just didn't know where to go with it, well, now you can see. So pause the video and fill out your book. Rewatch it as I explain it so it does make more sense to you. That's all there is to the lesson, though. It's a very short review lesson, very few practice problems. These are up here just in case you have questions, if you're not really getting it. I will walk you through it back in the back of the room. So if you need some extra help, please don't be afraid to ask. Come back to me, we'll go through 5 and 6 together. If you got this, not a problem, you're good to go, then it's a short lesson because there's not a lot to it, but there's a lot of drawing to it. So your assignment is on page 99 in your regular math book, questions 2 through 9, and then on the back, as always, we have 1 through 6. Remember, as I said in the earlier videos, 1 and 2 on the back is just like what you're doing on the front. 3 through 6 are a review of things we have done up to this point. If you have questions then, please come and ask. If not, have your assignment done for tomorrow.